Lesson 2, powers of 10 and 0 exponents. So we're going to see standard form. What's another name for standard form? Hands up, please. Liddies. The answer. Good. There's one more name for it. Who knows the other name? Starts with the letter D. Starts with the letter D. Don't holler it out. Don't holler it out. It's decimal form, okay? So this is also called decimal form. Okay, so decimal or standard form, we just want our answer. So we've got a pattern here. We've got 10 to the 9. How many zeros do you notice?
9.
There's 9. So the exponent's telling you how many zeros you have. So here I've got 10 to the 8, 8 zeros. What's my next one going to be? 10 exponent 7. And it's going to give me how many zeros? Good, 7 zeros. Okay. Then I'm going to have 10 to the 6. That's going to give me 6 zeros, 1 million. 10 to the 5, 100,000, 5 zeros. Then we have 10 to the 4, which is 4 zeros, 10,000. Let's move it up for you. 10 to the 3, or 10 cubed we can call him. It's going to give us 1,000. 10 squared, or 10 to the second power. 2 zeros, which is 100. It's like our percentages are out of 100. Do I have to show a little hidden 1 on the 10 exponent 1? No, he hides, but is it wrong to show him? No, it's not wrong to show him. So I have 10 to the 1 is just 10 with 1 0. Now what do you think is 10? What comes below 0, or the 1 here? What are we going to write? 0. I'm going to put 10 exponent 0. Now, that tells me I have no zeros. So what number is left after? Just a 1. Okay? So every time we go down, there's a pattern. Every time you go down, you're dividing by the base. And what's our base number? 10. So dividing by 10 every time, that's our pattern. Okay? So the pattern forms when you divide by your base. Let's take a look at powers of 2 and see how powers of 2 work. Alright, here's powers of 2. So let's start on the right hand side for our power. We've got 2 exponent 10, 2 exponent 9. What's next? 2 exponent 8, 2 exponent 7, 2 exponent 6, 2 exponent 5, 2 exponent 4, 2 cubed, 2 squared, 2 exponent 1, 2 to the 0, and now we get into the negatives, 2 to the negative 1. Okay. So what number is my pattern dividing by every time this time? It's dividing by 2. So my pattern, it divides by our base again each time. So that means I'm dividing by 2 each time. Now let's fill in our answer values. We can work from the bottom to the top. Let's start with 2 to the 1. 2 to the 1 gives me how big? 2. 2 squared is 2 times 2. How big is that? 4 times 2 is 8 times 2, 16 times 2,
64.
32 times 2, 64 times 2, 128 times 2, 256 times 2, 512 times 2. Good, 1024. All right, now let's go down to the bottom. We know we're dividing by 2 every time. So if I take 2 on the red side here on the left, I take 2 and I divide it by 2, and what's my answer? 1. If I take 1 and divide by 2, what do I get? If I take 1 and divide by 2, what do I get? Try it on your calculator. What do you get when you take 1 divided by 2? You get 0.5. So this is 0.5. We can write as a fraction 1 over 2. The fraction line means divide, so that's 1 dividing by 2. Yes, I can move it up for you. You got her? You're good? Okay. So do you understand we have a pattern here? So now we've got 1. The 1 divides by the 2, so we get our 0.5. But it's actually 1 over 2. So what do you notice that baby 2 has on his exponent? What's hiding? It's a hiding 1 always, right? If it doesn't show it to you, it's a hiding 1. Same as this 1 up here is a hiding 1. So now this guy here, 2 to the negative 1, is giving me this to the answer. So what is that showing you? Does anybody see a pattern there? What's happening between a negative 1 here and a 1 over 2 to the positive 1? Does anybody see a pattern on that by chance? Well, they're saying that this is equal. 2 to the negative 1 is equal to 1 over 2 to the positive 1. What do you think they did there? Can I make any number into a fraction? Yes. I do so by doing what to the bottom number? I put it as a 1. You can put any number over top of a 1 and you've made it a fraction. So I can take this 2 to the negative 1 and put it over 1 and now it's a fraction. So what do they think you did to this fraction to make it look like this? They flipped it, didn't they? But what do you notice happened when they flipped it? The negative became a positive on the bottom. Okay, and that's a rule we work with in grade 10. Okay, that's an extension for us. Okay, we're just seeing that right now the negative 1, it's going to go to 0.5. Okay, all right, moving on. What do you conclude from the patterns of the 2 previous tables with regard to anything? So n is any number, exponent is 0. So what is the little pattern we found with anything to the exponent is 0? Look through your stuff and what do you think? It equals a 1. Yes, you're correct. So anything to 0 always equals 1. So we can say the base and exponent both disappear. And are replaced by the number 1. Now hopefully you have enough room to write all that up in this little spot here. I just write really big for you. Yes, sir. Absolutely. Okay. Now, are there any other examples where that would be true? I want you to try a couple different numbers. I want you to put 1,000 exponent 0 in your calculator and see what you get for an answer. 1,000 exponent 0. And you get a 1 for an answer. Good. So what happens? This all disappears. It's gone. And it's replaced by the number 1. Okay? And that also works in BEDMAS when you have brackets. So let's take a look at a bracket question. If I've got a question that looks like this, let's go with 2 times 6 plus 9 divided by 3. If I put that, everything in brackets, all exponent 0, what do you notice is going to happen? You don't even have to solve anything. It's saying that the 0 belongs to everything, so that whole answer is going to disappear and give you a 1. Okay, so this will disappear. Okay, pretty handy trick. I like that trick. All right, you ready to move on?
Yeah.
Almost?
Yeah.
Not quite. I'll give you a minute to write that down. Our next exponent law is talking about the zero exponent law. We just discovered what happens when we put something exponent zero. So what is the zero exponent law telling us? It says a power with an integer base, so the base could be negative or positive, anything but a zero, then it has the exponent zero, the answer equals 1. That is what that's telling us. So we want to highlight something. Exponent 0 is equal to 1. That's what we would underline. Okay? Anything exponent 0 is equal to 1. Okay, so any base and an exponent with a 0 is 1. So I could put anything down. I could use variables. I could use the pi symbol. I could use anything. And then we're going to do the couple questions on the bottom here, okay? All right. So on the bottom, you're going to notice over here that we have n to the exponent 0 equals 1, but then we have this written here, that n cannot be 0. That's what that means, n cannot be 0. All that means is our base number cannot be a 0 number. Okay? It cannot be a 0. All right. Now we're going to talk about powers with 0. So if we've got exponent 0, what do we notice this guy is going to be? Oh, 1. But now we've got a floater negative. What do you think happens? Negative 1. Okay, now they're telling us our base is negative. It's a positive, so this would be a positive 4. So that's the same as saying 4 to the 0. So what's that going to give me? 1. Okay? And what do we notice about this one? This part would have been positive. Now I've got a floater negative. So it's going to give me a negative 1. Okay, is everybody following the negative rules? Excellent. Okay. Last page here of the notes. Says writing numbers using powers of 10. How do we use powers of 10? Well, it's kind of like scientific notation. So what we do is we find out the place value of the system. So if I've got thousands, hundreds, tens, ones, my decimal would be right here. That's my decimal. Okay? So over here, I need to see how many numbers I have. How many digits do I have here on the first one? I have 4 digits. So what I do is I take, and this guy has 4 digits, I take the very first number and I count how many digits are after the first number, and that tells me how many zeros I should have. So how many digits are after the 3? 3. So that means I'm going to have 3 times 1,000. Okay, thousands mean it's going to have 1,000, 3 zeros. Now I can say that a little differently, and I can put 3 times 10 exponent 3. Okay, because that little 3 there is telling me I have 3 zeros. Okay, then I go to the hundreds place. Now I look at the 4, and I see how many numbers are after the 4. 2 numbers, so that means I'm going to have 2 zeros. So now this one's going to be 4 times 100, 2 zeros. I could write that as 4 times 10 squared. Okay? And it says using powers of 10, so when I find these numbers here, I have to convert them to the powers of 10. Okay? Now I'm in the tens. So you look at the 5 number, and how many digits are after the 5? 1. So we're going to have 1 0. 5 times 10 with 1 0. Okay? So up here I'm going to have 5 times 10 exponent 1. Now I look at my very last one, the ones place. If I look at my number 2, are there any numbers after that 2? No. So that means there's going to be no zeros in my answer. So I'm going to have 2 times 10 exponent 0. Okay? So this is actually, hang on, it's actually 2 times 1. So up here we write 2 times 10 to the 0. because that 10 to the 0 part right here, that's what gives me my 1 for my ones place. Okay? So now when I write my answer, my full answer written in powers of 10 would be these ones on top. And we can't leave them sitting there like that. They each have to be put into brackets and a plus sign in between them. So I need to put them in brackets. Oh, I need to go over here. There, okay. So now I need to put these guys in brackets, all of them in brackets. And then I put a plus sign in between the brackets. Plus, plus, plus. Now that is properly written in powers of 10. Okay? Let's take a look and try the second one. Let's take a look and try the second one. How many digits are after the 4? 3. So I'm going to have 4 times 10 exponent 3. Let's look at the hundreds place. How many numbers are after the 5, including the 0? 2. So you're going to have 5 times 10, and there's 2 numbers, 2 zeros. Now, do I have a tens place? Is there a number there? No, there's nothing there. I don't fill that box in. There's nothing there. But is there a ones place? Yes, I've got a number 2 there. So I leave this guy blank. Okay, nothing's in there. And then now over here, I'm going to have 2 times 10 exponent 0. That's how I get my 1, remember. Okay, yeah.
In the third line there, they had one where the value was 0, but the things, and they filled it in.
Oh, they did. They filled it in, but honestly, you can just cross it off if you want to. Yeah, they did put the 0 times 10 just to show that it is in this place value. There's nothing there. Okay, to show you the 0 has a place value holder.
So we actually supposed to write the notes on that little line. No.
Oh, the exponents here.
Oh.
Yeah, we're going to write the exponents. We're not quite finished with this one right here. So this guy we have to write with our brackets now. So now we're going to have 4 times 10 cubed brackets plus 5 times 10 squared bracket plus. And then our very last one, 2 times 10 to the 0 bracket. Okay, so this guy's coming down, and this is how he's going to be written here. Yep.
If you did like a 0 times 10, would you add that?
You would not put it in here. Okay, if you have the 0, you wouldn't use the 0 one and put it in here. Okay? No. We don't even need to put that there. We can if we want, but we really don't need it there. It just is taking up a space knowing that the next number doesn't belong there because that's an actual 0. So if you want, you don't have to put 0 times 10 anything, just put a 0. Okay? Yes, sir?
I was going to say you were using the wrong symbol from multiplication.
Yes, well, it's scientific notation, so we have to use the times sign. Okay, when they're in brackets. Now, it's not wrong if you put a dot, that's totally fine. Okay, but because it's in scientific notation and powers of 10, we do use the times sign. Okay, we can use an X here, that's okay. All right, so now what we're going to do is we're going to try and figure out what this third one is. Okay, well, I know if it's in this row, how many zeros did I have? 3, so that's going to be 10 to the 3 there. This guy had nothing, so I could just write 0. Over here, it's in how many zeros here? 1, so it's going to be 10 exponent 1. And on the very end, 10 exponent how many? 0, good. So now I'm going to write that number. So if I write this number starting on the left, my standard form, I'm going to have a 7, and then what's next to it? 0. What's next to him? A 1. What's next to him? An 8. Perfect. You guys try the next one, please. You guys try the bottom row there. And then you're going to make your own. Make another number and try another number. So the bottom 2 rows fill out, please. I'll give you time to do that. Okay, let's try these ones together. We notice that this should be a 10 to the 3. This is going to be a 10 exponent 2, 10 exponent 1, 10 exponent 0. Now, if you have a 0 starting your number, you don't write it down. If you have a 0 in the middle, you don't have to write it down. But if there's a 0 on the end, you must write it down. So now I've got, starting with, I won't have to write him down. I start with my 6, then I have a 4, and yes, I need to include that 0 because it's the end of my number. So now I'm going to have a 0. Okay? Let's try this one. 1, 2, 3, 4. That's a fun number. 1, 2, 3, 4. Okay. What would this guy look like for me? I would have 1 times 10 exponent. 3. 2 times 10 exponent. 3 times 10 exponent. And 3 times 10 exponent. 0.
No, 4.
And now I just have to put them in brackets.
Oh, messed up. That's not the right number.
Oh, it's a 4. Thank you. I did mess up. Okay. Oh, not that one. That one.
You messed up again.
I messed up again. Okay. There's the 4. Perfect. Now the last thing you have to do is put it in brackets. So all you would have to do, quiet down please, is you put your brackets around all of them and little plus signs in between them. Okay? And then you've got a completed answer. Okay? That's the end of lesson 2.
Yay.
Wait.